Well, good evening. It's about quarter to six, I guess, on Tuesday evening, and I'm just thinking about the class and thinking about some ideas that I want to share. I want to talk about measurement. I have a very primitive setup here. I actually have a tablet that I can write on my computer, but it's really a very crappy program, and it doesn't work very well. So I'm just going to do this old school way, like something you'd see from YouTube 10 years ago or 12 years ago. In physics and in chemistry, we make measurements. Now, in chemistry, the measurements that we make are oftentimes milliliters or grams and whatnot. And we had talked about uncertainty. We talked about the fact that we have a certain number of significant figures that we can use when we make a measurement. And we have to carry those significant figures through our calculations. And I try to get the point across, although I don't know how much it hit home, that all measurements have uncertainty in them. So if you're using a measuring device, let me see if I've got one handy here. Oh my gosh, this is an old one from uh, my antiques here. But this happens to be a ruler in inches. And if I measure something, say I measure this pen, and oh, I wish I had a centimeter ruler. Well, let's just say I measure it, and I look at the end here, and this might look a little different to me than it does to you. You might estimate the length of something as, let's say, 15.8 plus or minus 0.5 centimeters. So we have some uncertainty of plus or minus 0.5 centimeters in that last decimal place. And that's going to depend upon your measuring device. Someone else might come along and make a measurement that says 29.2 plus or minus 4 centimeters. Let's say you're measuring a rectangle. And again, this is not to scale. And one measurement for the width is 15.8 plus or minus 0.5 centimeters, and the other measurement is for the length, 29.2 plus or minus 0.4 centimeters. And I want to say, well, what is the area? What is the area of this particular rectangle? Well, what we have to do is we have to be in a position to not only multiply length times width, but also treat these uncertainties in a very special way. So what we're going to do, first of all, is look at each measurement individually. So number one, we will look at the measurement of, let's call this the length and the width. And so we go ahead and say, okay, number one, let's figure out the percentage error in this measurement. So that's easy to do. It's 0.5 divided by, and that would be centimeters, divided by 15.8 centimeters times 100. And please know that your units cancel. And when you do that, you get 3.1646%. So that means in that measurement, you have 3.1646%. Of course, we're going to have to worry about significant figures at the end, not, we don't round yet, we round at the end. We don't want to make the errors worse. So then we look at number two here, the second measurement. We did that one, we did that, we're going to do this one. It's going to be 0.4 divided by 29.2. And once again, this is centimeters and centimeters times 100. Our units cancel as they should, and we end up with 1.3699% error in that measurement. Okay, next thing we do is we take the numbers and we multiply them. So we're going to go 15.8 centimeters. Always have to have a unit. If it doesn't have a unit, it doesn't have a meaning. Unless, of course, we're talking about something like pH and some other quantities that might be dimensionless. And we're going to multiply that by 29.2. And that's a centimeter as well. Let me check my calculation. And I'm going to go 15.8 times 29.2. And I get 461.36, and the units would be centimeter times centimeter, or centimeter squared. Okay, you with me? I hope so. But that's not the answer. That's part of the answer. We don't know how much uncertainty there is in that measurement. So what we have to do next is we have to say, well, we are going to go ahead and figure this out. So what we're going to do is take our two individual uncertainties and add those. So I'm going to say 461.36 square centimeters. I'm going to add these two values, and that will be 3.1646 plus 1.3699. And I get this value, plus or minus 4.5345%. Okay, now look, we've got two different units here. So that's, we don't like that. So what we're going to do is say, well, what percent, or what if I figure out the percentage, 4.5345% of 461.36 centimeters squared, what does that turn out to be? So you're going to multiply. Again, you've got to change that to a decimal. So it's going to be 0.045345 times 461.36 square centimeters. And when I do that, let me do it on the calculator here, 0.045345 times 461.36, and that works out to 20.9204 square centimeters. The units, of course, stay the same. So what we could do is we can go ahead and write our number this way. We say our number that we calculated for the area is 461.36 plus or minus 20.9204 square centimeters. Now, we have a lot of digits here, and we know that significant figures, we have to pay attention to them. We go back to our original measurements. Our original measurements have three significant figures, so we have to make sure that this value here has three significant figures. So 1, 2, 3, the next number is less than 5, so it's 461. Now I could put a decimal point there. We usually save that for a 0. If my last digit is 0 and we want 3 sig figs, we put a decimal point there. We don't have to. I'll put one there just for kicks. And plus or minus, well, if I look at this, these only have one significant figure. So if I look at plus or minus 20.92, you might be inclined to call that plus or minus 21, but we only want one significant figure. So what we're going to do is go ahead and call that 20 square centimeters. So, and again, I'm not putting a decimal point there. This is the only decimal that counts here for our significant figures. So the measurement of our area, because of the uncertainty in measurements, could be 461 plus 20 cubic square centimeters, which would be 481. So we say, oh, well, let's do it this way. We'll write it like this. We'll say bracket. Our measurement could be 441 square centimeters all the way up to 481 square centimeters. This looks a little bit like a confidence interval in statistics, but our measurement, we could say, is true somewhere between these 2 points. And that's when we talk about, oh, let me see here. When we talk about uncertainty in measurement, we have to carry that uncertainty through our calculations. When we need to in class, let's say we need to square or cube something, we'll go through that as well. And but most of the time we'll be multiplying and dividing, and it's the same idea. So that's a little bit on uncertainty in measurement. All measurements have uncertainty when we make them. Again, we're not doing pure mathematics like we do across the hall. We're doing measurements, and we're treating the numbers we're treating it numerically, we're treating it differently. So short video, only about 10 minutes long. Watch it at your leisure.